All right, here we go with lesson 6, multiple representations. We're still talking about y equals mx plus b. We're just going to talk about all the different ways that we can represent that. Verbal descriptions, equations, tables, and graphs. We're going to link them all together today. So the first example here talks about a baby giraffe, measures 6 feet tall when it is born. So remember, we talked about the y-intercept being a starting value. Well, what's better than a starting value than birth? Okay, so 6 feet tall when it's born. We're thinking right now that's going to be our b value. Okay, and it grows. Okay, well, another name for slope is growth. Okay, an average of 1/2 foot each month. Okay, so we're thinking right now that our m value is going to be 1/2. Okay, so x is the number of months and y is the height of the giraffe. Let's build our equation, right? So remember, all of our equations are y equals mx plus b for now. All right, and we've gathered that information, so we want to plug those things in for the m and the b. Notice how I still have y equals x plus okay, and I'm plugging in my values that I have for each of those. So 1/2 x, okay, plus 6 would be my two values to make my equation. Okay, now how does that equation relate to the table? Some of you have already started that on Desmo or Delta Math, so you know how those two are related. So I'm going to go ahead and just copy that equation down here. Okay, so y equals 1/2 x plus 6. Okay, months is x. The problem tells us that. Okay, the height is going to be our y value. All right, the process is how we calculate that. So in month 0, I'm going to take 1/2. Okay. And I'm going to plug a 0 in for the x number. Then I'm going to calculate that with my calculator. Okay, so 1/2 times 0 is 0 plus 6 is 6. That's my y value. Then I'm just going to repeat that process, okay, for every value in the table. Now, you can get kind of good at this, right? Because really I'm doing the same thing over and over again. So essentially, I'm just copying that 1/2 plus 6. And what am I filling in there each time? I'm filling in this x value. All right, so when x is 1, 1/2 times 1 is 1/2, plus 6 is 6.5. Okay, and then when x is 2, I'm putting 1/2 times 2 plus 6. So 1/2 times 2 is 1, plus 6 is 7. All right, and I just continue that process. So go ahead now and finish that up, plugging in x for each of those, okay, all the way through the table till we get a full table of values. And here's what I ended up with. All right, so 1/2 times 3, okay. Sorry about that. One half times 4, 1/2 times 5, 1/2 times 6. For some reason I can't write in there because I already have the erase. I use the erase feature, so okay. Anyway, so those are the values that I get, okay, in my table. Then I want to plot these, right? So I don't have to plot all of them, right? Because those 0.5s are kind of messy. So plot the ones that are whole numbers. Okay, so first I'll plot 0, 6. That's my starting value. I'm going to skip over 1, 6.5 and go right to 2, 7. So I'm going to plot 2, 7 next over 2 up 7. And then I'm going to plot 4, 8. And then I'm going to plot 6, 9. Once I have all my points plotted, I'm going to draw my line. Now, I know I told you want your line to go the whole way across the grid, arrows on both ends. In a situation like this, where we're talking about something that's being born and growing, okay, we're not going to put an arrow at this end, right? Because it wouldn't have been born prior to that. But that all depends on what the situation is. So we have our verbal description. We translated that to our equation, right, into the table, and then finally the graph. Now, what we want to get good at is it shouldn't matter which of these 4 options I give you to start. You should be able to generate the other 3 parts to that. And once we do that, that's the type of understanding we want to have of this material. Let's go down here and answer some questions. Explain how you found the ordered pairs to create your graph. Okay, well, I plugged x into the equation and I calculated y. What is the slope of the graph and what does it represent? The slope is 1/2 and it's how many feet the giraffe grows per month. It says it in the problem, 1/2 foot each month. What is the y-intercept of the graph and what does it represent? Y-intercept is 6 feet, and it's the height of the giraffe at birth, beginning, initial value. What does the ordered pair 9, 10.5 represent in the context of the situation? Okay, after 9 months, the baby giraffe will be 10 feet, 6 inches. I have 5 inches there, it should be 6. 10.5 feet. Okay, and I can't right over top of that. All right, and then the last one here is when will the giraffe be 12 feet tall? So I just plug 12 in for y now because I'm looking for the height of 12 feet. So I plug 12 in for the y, and I solve that equation for x, and I got 12 months. That might be a little past where we're at right now, but I think it's worth sharing. Okay, so that's the expectation for these multiple representations. I'd like you to go ahead and turn the page. And we have 2 here, okay? The first one, I blocked out some things, all right? They don't give us a verbal description, but they do give us the equation to start, 12 plus 1.5x. And we're talking about Joey's Pizza Parlor. Okay, so you want to think in your mind, what could the 12 represent if it's a flat rate? And then what could the 1.5 represent if it's the part that's growing? All right, I started out with some things that I knew. So the first thing I did with the equation is graph it. Okay, I can graph regardless if I know the situation. So I did change that 1.5 to 3 over 2. That's up to you. You don't have to. It's just, to me, it's a little bit easier to go up 3, right 2 than to go up 1.5, right 1. And I went ahead and graphed that equation. So now I already have part of my problem completed. The one thing I needed to notice when I graphed, though, is that the y-axis was counting by 3s. So I had to be careful there. Okay. From there, I went over to the table. Okay. I still thought that was easier. So I plugged in 0 for x in my equation, and I got 12. And then I went down through the list, and the table tells me toppings, so that gives me an idea about my verbal description. And I plugged in each of those x values to that equation over and over again, used my calculator, and calculated the total cost. Now I was forced to come up with a verbal description of this. Okay, so the flat rate would be the cost of a cheese pizza, and the 1.5 slope would be $1.50 per topping, is what I came up with. Now, you could have done that in really any order you wanted to. Okay, I did it in the order that made the most sense to me. The parts, I just did the easiest ones first and worked my way through. And the next situation here talks about the Smith family road trip. And again, here all they give us is the table and some values in the table. So I can plot those, right? That's where I started. So the x values here are the miles driven. The y values is the gasoline. So I can plot those points. So I plotted 10. I plotted 10, 8.5. I plotted 28. I plotted 47, so forth, right? Got my line. So at least I have some of this done now. I didn't have an equation yet, so I had to kind of figure that out. Well, once I had the graph, it made it easier to find an equation, because on the graph, I can see that my y-intercept is 9. I can see that I'm going down 1, right 20. Okay, so be careful there. It is down 1, right 20, based on how the x-axis is counting. So now that I have my graph, which I can get from my table, it's easier for me to write my equation. So negative 1 over 20, x plus 9. All right, that allows me to fill in the rest of my table by using the equation I just came up with. And again, if you're looking for that slope, you could have just used slope formula there, right? Just another way to get the same answer. So 8.5 minus 8, and then 10 minus 20. And that would give me my slope for my equation. Probably a messy decimal. That's why I like doing the graph first, because it's a little bit easier to count slope on a graph. And now I had to come up with a situation. So it's a family road trip. We're talking about gallons of gas remaining. So I'm going to say that they had 9 gallons of gas, and they're using 1 gallon of gas for every 20 miles on their road trip. So a pretty short day there. Just trying to make some connections between all the different ways we've been seeing y equals mx plus b. And we're getting close to the end of the unit here.